For our tutorial question today, we are in question 30, and this question 30 is drawn from application of differential calculus, and the specific area is rectilinear motion. Now the question reads, a particle starts from rest and moves in a straight line in such a way that its velocity v meter per second at time t seconds is given by v equals to 3t squared minus 6t. Then calculate the acceleration in the third second. Now let us remark this statement in the third second. I'm going to explain this as we continue. Now let's go further. From this question, we can see here that we are dealing with rectilinear motion, where we are asked to look for the acceleration given the velocity as 3t squared minus 6t. So we'll write out our v, and that will give us 3t squared, then minus what? 6t. Now for us to get the acceleration is actually the derivative of dv dt, that is the rate of change of velocity with time. Now what this means is that given this velocity function, we are going to differentiate it with respect to t, and that's what we have here, dv dt. So in doing this, we can say 2 times 3t will give us 6t, then 2 minus 1 is 1, then minus, this place here we have 6, and here we have 1. 1 times 6t will give us 6t, then 1 minus 1 is 0. So the next step is that we have 6t minus 6, because t power 0 is 1. So this is the acceleration. Now, coming back to what I said here, we have to calculate the acceleration in the third second. Now, you have to be very careful here. If you are not careful, you would think they are asking you to put t as 3. No. Yes, it's in the third second. So we are actually going to say here that t is equals to what? 2. And in doing this, if we plug in the value for t into this derivative here, we are going to have 6 multiplied by 2, then minus 6. And if we do this, we are going to have 6 times 2 is what? 12. 12 minus 6 will give us 6. And because we are dealing with acceleration, we can say meter per second squared. And this is the answer to this question.